Okay, today we're going to work on the metric system. Okay, so first thing we're going to do is we're going to make some observations. First of all, we notice, hey, here's this power of 10 to some exponent. Kind of looks like scientific notation, and then you look over here and you see that. That's why we did scientific notation first, so we can understand how it works. Notice that we have a number 10 to the power of 0. That gives us 1. That's our base right there. And this is our base unit. I'm using the example of meter. Okay, so 1 meter. 1 times 10 to the 1, well, we know that equals 10, right? And the unit then is meters. So 1 times 10 to the 1 is 10 meters. So 1 times 10 to the 2, 100 meters. And 1 times 10 to the 3, that would be 1,000 meters. Now, notice that 1 times 10 to the 1, that's a 1 with 1 0 behind it. So there's 10. 1 times 10 to the 2, it's a 1 with 2 zeros behind it. 1 times 10 to the 3, it's a 1 with 3 zeros behind it. Notice how if we use this is a 1, and it's got 12 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. That's a huge number. I mean, clearly writing the number in scientific notation is much better than writing out a number that looks like that. So, how are we going to use this power of scientific notation, these powers of 10, to help us with the metric system? Well, if you go up by 1, 10 to the 1, that's called deca. If you go up by 10 to the 2, by 100, that's called hecto. 1,000, 10 to the 3, that's kilo. 1,000,000, that's a mega. 10 to the 9th is giga, and 10 to the 12th is tera. And there's other ones too. I mean, you can go 10 to the 15th, 10 to the 18th, 10 to the 21, 10 to the 24. There's more to the metric system than what I've put here. But this is a good start. And so we can see that, yes, the very small 1 times 10 to the negative 1, that's 1 divided by 10. So that's going to give us 1/10. And 1 times 10 to the negative 2, 1/10 of a meter. I forgot my unit. 1 times 10 to the negative 2, that's going to be 100th of a meter. And 1 times 10 to the negative 3, that's going to be 1,000th of a meter. 1 to the negative 6, that's going to be 1,000,000th of a meter. So 1, 2, 3, 4, 5, and then put a 1 here for our number right there. Okay, so this is how it works. And so we have deci is 1/10, centi is 100th, milli is 1,000th, and micro is 1,000,000th. This little symbol that represents micro, it's a little mu. So you put a little tail on it and then you make a little u. This is mu. It's pronounced M-U. It's a little Greek symbol, mu. And so this is a micro. So 1 micrometer is 1 times 10 to the negative 6 meters. And this little symbol here is the Greek symbol mu, M-U. Okay? So you might say, well, this is great, but I know that there's 3 feet in a yard and there's 12 inches in a foot, and I don't understand this meter stuff. Well, those conversions will come, but first let's look at how this chart can help you. If I said you had 1 meter and I asked you, how many centimeters is that? And you would look on here and say, well, 1 centimeter is 100th of a meter. So that would give me 100 centimeters is equivalent to 1 meter. 1 centimeter is 100th of a meter. So if I have 1 meter, then I'd have to have 100 of those centimeters to get a meter. So what if I said you have 1 kilometer? So 1 kilometer. How many meters would you have? And you'd say, well, a kilometer is 1 times 10 to the third. It's a power of 3, so it's 1,000. It tells me I have 1,000 meters. That's great. 1,000 meters. So now, what if and so we just did that by the power of 10. So now, what if I said we have 1 kilometer, but now I want to know how many centimeters do we have in 1 kilometer? Now that might be a little different because, wait a minute, centimeters, kilometers, that's mingling both of these, isn't it? Well, if for every 1 meter we have 100 centimeters, and we have not just 1 meter, but a 1 kilometer or 1,000 meters, so now we're going to have a power of 1 to the 3 and a 1 to the 2. That's a power of 1 to the 5. Notice that the steps here, we have 1, 2, 3, 4, 5 steps. So 5 powers of 10. That gives us 1 times 10 to the 5th. So 1, 2, 3, 4, 5. 1 to the 5th centimeters. So it's a real easy way to convert. And you might have some issue with what I just did. You might say, well, I can't do that in my head. Perfect. Because this is what I want to show you. If you have, let's just say you have 40 centimeters. And I want to know how many kilometers that is. Well, how many centimeters are in a meter? Well, you'd say, well, there's 100. So I'm going to use my conversion, 100 centimeters in 1 meter. So the centimeters are going to drop out. And you might say, well, that gives me meters. That doesn't give me kilometers. Right, but put another bracket here. Put another bracket, and you know that there's 1,000 meters in 1 kilometer. 1,000 meters in 1 kilometer. The meters will drop out, and we'll have 40 divided by 100 divided by 1,000. So what's that going to turn out to be? Well, if you have an issue with that, you can get your calculator and you can say 40 divided by 100 and divide that by 1,000. And that's going to give you 4 times 10 to the negative 4. So, and then that's going to be kilometers. So, get your calculator out if you need to. That's fine. Just, you don't have to do everything in your head. Get your calculator out and let your calculator work for you. If you do these problems in your head, great. If you need a calculator, wonderful. The point is to get the right answer. And whatever method you need to use to get the right answer, you need to do that. Let me ask you another question. What if I had 1 can of, let's say I wanted to buy 1 soda. You see, and each soda will cost 50 cents. I'm going to let each soda cost 50 cents. And let's say that I wanted to know 1 soda, then that would be 50 cents. So if I wanted to purchase 1 soda, I know that I would have to spend 50 cents. And that's no big deal. You might say, well, I could do that in my head. That's easy. Well, of course. That's great. What if we wanted to buy not 1, but 4? So we wanted to buy 4 sodas, and each soda was 50 cents. Well, then you would say, well, that's easy. 4 times 50 is $2. Okay, good. 4 times 50 cents is $2. That's how much it cost. Wonderful. Is there really anything different between these two problems? These two problems are using this conversion factor, this equality. That's exactly what these are. Equalities. 1 kilometer is equal to 1,000 meters. 50 cents is 1 soda. All you're doing is using conversion factors from one form to another. So you'll need to practice those and make sure that you're able to convert from one part of the metric system to the other. That'll be on part of your homework, so you'll see how that gets done. Let's see. What we need to, Now when it comes time for your homework, you're going to need to have memorized this metric system. You're going to need to know all of those values. So part of your assignment today is to learn the values. Know what the metric system is composed of. You'll have to be responsible for all of the units and all of the factors. So what I'll do is I might ask you a typical question would be, say I wanted to know what if I had say I had 1,000 kilometers. How many mega meters is that? Well, between mega and kilometer, there's a factor of 3. That's 1,000. It takes 1,000 kilometers to make 1 megameter. Oh, well, that's what I have. So then that unit would be 1. Or we could solve it this way. If you have 1,000 kilometers, how many megameters is that? Well, 1,000 kilometers. In each kilometer, it says that there's 1,000 meters. So 1 kilometer is 1,000 meters. Okay, and then those kilometers drop out. Then when we have we want mega, it says here 1 megameter is 1,000,000, 1 times 10 to the 6 meters. So I have 1 times 10 to the 6 meters in 1 megameter. So I have 1,000 times 1,000, which is 1 times 10 to the 6, divided by 1 times 10, divided by 1 times 10 to the 6. So that's going to give me 1 megameter. Good. So I'll ask you to do conversions like that. I might just say 1 kilometer is equal to, and then you'd have to tell me what that equals. So those are types of typical questions. Now, the other part of today's lesson is learning something called mass and weight. These two words have different meanings. Your mass is the quantity of matter a sample contains, but the weight is a measure of the attraction of gravity for that sample. So let me describe the difference between these two, and then we'll look at a quick problem or two. So here we have the spaceman, and he's on the moon or somewhere, and this spaceman is out in space. It's the same spaceman. It's the same guy. He has the same mass, but his weight is going to be different because in this case he's on the moon, and in this case he's in deep space. Notice that if you're on the moon, he's got more of a gravity attraction for the moon, so he has weight. But when he's out in space, deep space, he's weightless. Let me draw a picture. It turns out that the Earth is almost round. We'll just say it's round. Now, your weight depends upon how far you are away from the Earth. So let's just say that we're standing right here if we stand right here on top of the Earth, so let's just say we're at the North Pole. So if we stand at the North Pole, we have a certain weight. What happens when we climb a tall mountain? That's a huge mountain on the Earth, by the way. And we climb up on a tall mountain and we measure our weight right here. Well, here we were closer to the center of the Earth, so we have more weight. Here we're further away from the center of the Earth, so we have less weight. Well, what if we go so far out in space that we are really, really far away from that? Notice that we are weightless. So notice that we go from a weight that is the strongest to a weight that is reduced. So, in fact, it goes all the way to 0. So, mass and weight, two separate things. Same guy, same mass. Different places, different weights. So, your mass is constant, but your weight will change depending on where you are in the universe. So, that's an important concept to understand. So, I need you to make sure that you understand that concept. So now what we're going to do is do a quick problem. And it's a very simple problem, and it's based upon the English system and the metric system, which we'll discuss in a few lectures. But what we have to do is, in America, we use this system called pounds. And it turns out that everywhere else in the world, they talk about kilograms. Well, pounds is weight and kilograms is mass. But luckily for us, there's an approximate conversion factor. And I say approximate, but we're going to use the simplest case. There are 2.2 pounds for every kilogram. 2.2 pounds per kilogram. So if I have something, let's say I have 100 pounds, something that is 100 pounds, and I want to know how many kilograms that is, this is my conversion factor. Notice that pounds has to be placed in the denominator, 2.2 pounds has to be down here, and 1 kilogram has to be up here. Okay? Now, I can't do that in my head. 100 divided by 2.2, so I pull out my calculator. 100 divided by 2.2, and I get 45.45. So let's just say 45. One of the things you're going to find out is that my 5s look a lot like 6s. Sorry about that. So 45 we'll say roughly 45.5 kilograms. And so 45.5 kilograms. So the pounds drop out and I'm left with units of kilograms. So when you say 100 pounds, that's 45.5 kilograms. So in your mind, I want you to think kilograms is always less. Kilograms is always less than pounds. So think of it like this. If a typical student who was in high school weighed 140 pounds, how many kilograms? What would their mass be? Well, it would be 2.2 pounds for every kilogram. And so 140 divided by 2.2. 140 divided by 2.2. And you'll get 63.6. 63.6 kilograms. And you might say, okay, I get it. It's less. Well, think of it also like this. Would you rather think of someone who's concerned about their weight? Would they rather say, I weigh 140 pounds, or I weigh 63.6 kilograms? I mean, it sounds like, oh wow, that's a lot less. 63.6, yeah, it's smaller. So what if I had what if I wanted to go the other way? What if I wanted to go from kilograms to pounds? Let's just say I have something that's 100 kilograms. How many pounds would that be? 100 kilograms? How many pounds? Well, for every 1 kilogram, there are 2.2 pounds. So the kilograms drop out, and 100 times 2.2, well, that's going to be 220 pounds. So someone that has a weight of 220 pounds has a mass of 100 kilograms. So that's how that works, that pound to kilogram conversion. That pound to kilogram conversion lets us know the difference between weight and mass. Weight is in pounds, mass is in kilograms. Mass will not change. Your weight will change depending on where you are in the universe. Okay, it's time to get started with the homework questions. So good luck to you.